Ever wondered how it all began?
Our current understanding of the Big Bang is inadequate and insufficient, but there are some factors of the Big Bang that we are aware of. After much studies and research, scientists have concluded that our universe began as a singularity. Ironically, nothing much is known of a singularity. Singularities are one of the unknown areas of science, and it defies our current understanding of physics. A singularity is said to have existed in the core of a black hole. These are areas which have high gravitational pressure. This pressure is so high that it is said to crush finite matter into infinite matter. This mathematical concept still has mathematicians on the run as it is hard to solve. A singularity is infinitely small, hot, and dense.
The black hole's immense gravity pulls everything down to an unimaginably small point at its center. Scientists call it the singularity.
We really just don't know what happens at the center of a black hole. The densities are so great that the laws of physics break down, as we know.
The universe then inflated and sprang into existence about 13.7 billion years ago. The phenomenon of this explosion gave it the name the Big Bang.
After this explosion, the universe has expanded, and to this very day is still expanding at an accelerated rate, in just less than a second. The magnitude of the expansion was so tremendous that it was expanding faster than the speed of light. During this period, the universe doubled in size almost instantaneously more than 90 times, moving from a size relatively smaller than an atom to larger than a golf ball. As space expanded, it began to cool drastically as well. As such, matter was formed. The universe was filled with protons, neutrons, electrons, anti-electrons, photons, and neutrinos in just 1 second after the Big Bang. The law of gravity plays a big role in the mechanics of the universe as well. The law states that every particle of matter is attracted to every other particle of matter. To be precise, particles will attract one another with a force proportionate to their masses and inversely proportionate to the squared radius. The equation for the force of gravity is gmm over r squared. M and m are the two masses of the objects in the system, and r squared is the radial distance between those two objects. Now g is the gravitational constant. Basically, the gravitational constant is the proportionality of the two objects with no regard to their masses, and this constant has a fixed value of 6.672 times 10 to the power of negative 11 Newton meter squared per kilogram squared.
The theory of relativity states that all motion must be defined relative to a frame of reference, and that space and time are relative, rather than absolute concepts. The theory itself is divided into two principal parts, which is the special theory of relativity and the general theory of relativity. This theory was developed as an attempt to unite the laws of mechanics with the laws of electromagnetic fields. The special theory of relativity is basically Einstein stating that distance and time are not absolute parameters and depend on the observer. This statement leads to the famous formula that connects the mass of an object to its potential energy, also known as E equals to mc squared. This formula is based on the fact that light moves at a uniform speed at all frames. This theory is called special because it doesn't apply to objects that have an accelerated motion. The general relativity is the geometric theory of gravitation published by Einstein in 1950 and the current description of gravitation in modern physics now. The general relativity is also called the equivalence principle because it is a generalized version of the special theory of relativity. It states that gravity pulling in one direction is equivalent to the acceleration in the opposite direction, and both are equivalent to the curvature of the space-time. The general theory of relativity relates to more than the Big Bang compared to the special theory of relativity. The Big Bang is a particular solution of general relativity equation that is believed to obey boundary conditions and the observations of astrophysics about the early universe.
Hubble Space Telescope was used to observe and identify smaller galaxies. And it was found that these galaxies are much further apart they were today than they were many years ago. And this is due to the fact that the universe is expanding. The theory was then continued by Arno Penzias and Robert Wilson using the discovery of the cosmic microwave radiation. And they realized that this radiation again came from the expansion of the universe.
Additionally, it is said that the universe's light element abundance was created right after the Big Bang. Light elements, namely deuterium, helium, and lithium, were produced the first few minutes just right after the Big Bang. Using the model of the Big Bang and via observation, it's been proven that the Big Bang's hypothesis is further verified.
One of the most famous theories about the origin of the universe is the Big Bang theory. The Big Bang theory is the explanation of the birth of the universe, but it might not be quite as stable as scientists or astronomers previously thought. Two scientists, Das and Ali, proposed that the universe is filled with quantum fluids which made up of gravitons and particles which have no masses themselves, but transmit gravity the way photons carry electromagnetism. When Ali and Das made small quantum corrections to Ray-Choudhury's equation, they realized it described a fluid made up of small particles that pervades space. Physicists have long believed that a quantum version of gravity would include a hypothetical particle called graviton, which generates the force of gravity. In their new model, Ali and Das proposed that such gravitons could form these fluids.
The behavior of the fluid back through time. Surprisingly, they found out that it did not converge into a singularity. Instead, the universe appears to have existed forever. Although it was smaller in the past, it never quite crunched down into nothing. There is a theory which relates to the theory of quantum fluids to the universe itself, which is Einstein's general theory of relativity. With the general theory of relativity, in which Einstein managed to reconcile relativity and gravitation, he had to discard the traditional physics worldview, which saw space as merely a stage on which the events of the world unfold. Instead, space and time is a dynamic entity, which can be distorted by any matter that is contained in it, and which in turn tells this matter how to move and evolve. This interaction between space, time, and matter is described by Einstein's geometric relativistic theory of gravity.
Quantum fluids also exhibit the properties of a fluid at absolute in zero temperature and zero pressure. The meaning of absolute zero is that it is the lowest point in a thermodynamic temperature scale. This effect rises due to a large zero-point energy level and their small interatomic energies. These prevent them from forming a solid vase. Zero-point energy is the lowest form of energy that a quantum mechanical physical system can have. This results in motion even at absolute zero. For an example, liquid helium does not freeze under atmospheric pressure at any temperature because of its zero-point energy. In that case, we can imagine why our universe is fully dark and in space the temperature is so low.
Quantum fluids can also be referred to as superfluids, which are made up of atoms. Superfluids are capable of flowing endlessly without energy loss. Only liquids and gases can be called superfluids. Helium has a freezing point of 1 Kelvin, which is the absolute lowest for any element. However, when it reaches a temperature of 2 Kelvin, it begins to exhibit superfluid properties.
This rapidly evaporating liquid helium cools until at 2 degrees above absolute zero, a dramatic transformation takes place.
Suddenly, you see that the bubbling stops and that the surface of the liquid helium is completely still. The temperature is actually being lowered even further now, but nothing particular is happening. Well, this is really one of the great phenomenon in 20th century physics.
the liquid helium had turned into a superfluid which displays some really odd properties.
Here I have a beaker with an unglazed ceramic bottom of ultrafine porosity.
Ordinarily, this container with tiny pores can hold liquid helium. But the moment the helium turns superfluid, it leaks through.
We call this kind of flow a superflow.
Superfluid helium can do things we might have believed impossible. It appears to defy gravity. A thin film can climb walls and escape its container. This is because a superfluid has zero viscosity.
This transition phase occurs when all the constituent atoms begin to occupy the same quantum space. This happens when the atoms are placed so closely together and cooled so drastically that the quantum wave function begins to overlap. The atoms then lose their individual identities, thus behave more like a single superatom rather than individual original atoms. Even with this discovery, scientists are still mulling over the quantum fluid theory. As such, Das and Ali's mathematical equation still does not prove that the Big Bang never existed in the first place.
An alternative to the Big Bang theory will be the black hole theory. To understand this black hole theory, one must first understand what is a black hole. A black hole was first introduced by Einstein through his theory of relativity. When a star with a huge mass collapses, it forms a black hole. A black hole warps time and space so severely, and it has a high gravitational force. This gravitational force allows a black hole to devour anything that comes in its path.
Also important to note is the presence of an event horizon belonging to a black hole. The event horizon is a space-time boundary of the black hole. At this boundary, light and matter can only pass inwards into the black hole, and nothing can escape it. This is the main reason why black holes are so mysterious, because whatever happens while within the event horizon cannot be observed by anyone from the outside.
As for the theory itself, it is suggested that a four-dimensional universe collapsed into a three-dimensional black hole, that our universe exists outside the event horizon of the black hole.
This very idea stems from the speculative theory that to a black hole there has to be a white hole, and they are exact opposites. A black hole can only be entered from the outside, and nothing can escape from it. On the other hand, a theoretical white hole can only be entered from the inside and emits light as well as matter. Thus, it is believed that energy and matter falling through a black hole from a higher dimensional universe comes out through a lower dimensional universe through a white hole.
Black holes might even be gateways to other universes. On the other side of a black hole, there could even be a Big Bang.
As a black hole collapses and matter falls into it, perhaps the matter is blown out the other side in a white hole. Doesn't that sound like the Big Bang?
If a Big Bang is just the flip side of a black hole, this could be how our own universe was born.
If you look at the equations for a black hole and put in the parameters of the universe, the mass of the universe, the size of the universe, bingo, you find that our universe actually solves the equations for a black hole. In other words, we could be inside an event horizon. Perhaps we are actually living inside a black hole.
Now this concept is basically explaining a wormhole, which is another theoretical concept more commonly known as time travel. This is because wormholes are said to provide shortcuts if one were to travel across the universe. The thing about this theory is that it can neither be proven nor disproven, because the fact remains, we cannot see beyond the event horizon.
According to Einstein's theories, at the center of the black hole, there is a hypothetical singularity, a point or seed so infinitely small and so infinitely dense. Known physicist Dr. Popolowski says that the difference between the black hole singularity and the hypothetical singularity of the Big Bang is that the one in the black hole is real. Come a point, this matter can no longer be crushed any smaller.
The competing process helps, according to Dr. Podolsky, because the black holes spin. They spin extremely rapidly, possibly close to the speed of light. It is not just small and heavy, but it is also twisted and compressed, like one of those junky spring-loaded snakes in a can, which can suddenly unspring with a bang. Make that the Big Bang, or what Dr. Podolsky called it, the Big Bounce.
The motion of matter through an event horizon would only happen in one direction, and it is this time of direction that we perceive as moving forward. The arrow of time in our universe would therefore be inherited through torsion from our parent universe. Torsion would also explain the observable imbalance between matter and antimatter in the universe. Through torsion, matter would decay into the familiar electrons and quarks, whereas antimatter would decay into dark matter, a mysterious and invisible matter that is part of the majority of the universe.
Torsion could be the source of dark energy, a mysterious form of energy that permeates all of space and increases the rate of expansion of the universe. Geometry with torsion naturally produces a cosmological constant, a sort of added on outward force, which is the simplest way to explain dark energy. Torsion therefore provides a theoretical foundation for a scenario in which the interior of every black hole becomes a universe.
Nevertheless, the theory raises some questions. If we are living in a collapsed star, a three-dimensional black hole belonging to a four-dimensional universe, then how did the previous universe come to be? If it was born the same way ours was created, then it opens to a question as to how the universe or black to existence. It's similar to the chicken and egg problem. Which came first?
The problem also poses a different kind of question. If we are in a three-dimensional universe and our parents' universe is in a four-dimensional one, then how many dimensions could the first universe have been? Is it existed? And of course, most of these explanations are theoretical and hypothetical. Unlike the Big Bang theory, it is mathematically explained.
Then, sure.
For the most part, the Big Bang theory prevails as the leading and most prominent explanation of the birth of the universe. In this statement, is supported fully by the scientific community. Multiple documentaries and written reports have been released in order to analyze the concept of further. Yet to this very day, the origin of the universe is still remained as one of the greatest mysteries ever known to the mankind.